Dear students, today we are going to talk about another type of nuclear reaction which is known as fusion reaction. In this reaction, what happens? Two lighter nuclei come close enough to combine together. How this is possible, we will talk about it. In this type of reaction, what happens? The binding energy of the final product of the nucleus produced after fusion is certainly less than that of the combining nuclei, and therefore there is some release of energy, and this energy can be utilized for the benefits of mankind, providing power and all sort of comforts to human being, and also it provides a clean energy. Here there are a few options. It could happen, more than one reaction may take place out of these, or either of them may take place. See, 1H1 combining with 1H1 gives 1H2, means it is another isotope of hydrogen, and releases positron, neutrino and some energy. There could be another option that 1H2, that is deuterium, added with deuterium produces an isotope of helium. 2He3, a neutron is released with some energy, which is nearly 80% of the heat energy released due to the reaction, and that heat energy is of the order of 3.27 mega electron volt. Now we have yet another option that 1H2 plus 1H2 combining, fusing together produces 1H3 and 1H1, and also releases some heat energy. So in this case, you see that whatever the byproducts are, they are not radioactive in nature. They are only having large kinetic energy, which finally converts into heat energy. Now, how this type of reaction can be artificially made possible? Because this happens in nature. In sun, you see, this is the root source, main source of energy, which produces light and heat. Well, there we have high pressure and high temperature maintained due to high gravitational pull controlling all the fusing nuclei, and also it is having these fusing nuclei present over there in abundance. But here, if we want to produce it artificially, we need to create very high temperature of the order of 10 to the power 8 degrees Celsius, because only then we can have those nucleons brought very close to each other, so that it comes within the range of strong nuclear forces, and that will then capture it to fuse, and the two lighter nuclei will fuse together. So high temperature is needed, and once we create the high temperature, what is happening, that the material converts into plasma state, because at certain temperature beyond few thousand degrees, all the metals converts into plasma state, means in ionic state. All the orbital electron gets enough energy to get them free from the parent atom, and in this case the matter is said to be in plasma state, the fourth state of matter. Now if we want to contain it somewhere in some container, that container itself will melt out at that high temperature. Therefore, containing in any container is not possible. Then how is it possible? Here we apply a technique which is known as tokamak technique, or we have already discussed it in this class in the chapter of magnetism, that how a magnetic confinement can be made. Magnetic confinement means anything which is lying in a space and moving between the two poles of a magnet in a spiral path, and without getting in touch with any container, that material can kept revolving, kept swinging between the two poles if the particle is charged. And here it happens that the nucleons are positively charged, therefore nucleus are positively charged, therefore we are in a position to have the magnetic confinement of such plasma matters, that is the fuel for fusion reaction. So that technique is employed over here, and then once it is done, how we are going to maintain the temperature of that fuel, because if the plasma is at such a high temperature, it is very much clear that it will lose energy very rapidly due to radiations, and therefore we need to compensate this loss of heat. How we are going to compensate it, with this loss of heat, so that the temperature is maintained, which is just enough to carry on the fusion reaction. Now this loss of heat can be compensated by a few ways, out of which I believe the best way is by using radio frequency waves. We use electromagnetic waves which are having frequency of the order of the natural frequency of those nucleus of the fuel. Here when we inject the electromagnetic waves on them, when we incident the electromagnetic waves on them, the maximum energy is transferred to the nucleus because of the resonance phenomena, because the frequency of the radio frequency is kept equal to and matching the frequency, natural frequency of the nuclear fuels, which are the fuels for fusion. So in that way we can compensate the heat loss by the hot plasma material. Now there is another thing, that how we are going to sustain this nuclear reaction. This can be sustained by just compensating the heat loss, and once this rate of reaction is high enough, then what happens, out of the 20% of the energy released due to this fusion reaction is carried by the alpha particles, and these alpha particles are also get trapped within the magnetic confinement techniques, and so these alpha particles can serve as the heat compensation sustainable method. Means this 20% of heat was generated and given to the alpha particles by the reaction, nuclear fusion reaction itself, and if this 20% is having enough heat to compensate the heat loss by plasma, then the nuclear fusion reaction can be sustained by the heat produced by the fusion reaction itself. So this is the technique which is being used, and the neutrons which carry a large amount of heat get ejected out of that magnetic confinement, because these are neutral particles, and once they come out, their heat energy is absorbed by the absorbing fluid, and which is then used to heat up and produce steams, which further produces the electricity by using a turbine and a generator system, as we have done earlier in case of nuclear fission reactors. Well, here you see we apply toroidal magnetic field within which the plasma particles keeps rotating and are having a nuclear magnetic confinement in this zone. The whole world is still learning better technique to maintain the fusion reaction, because in this fusion reaction we don't have the byproducts as radioactive material, so it is a clean source of energy as compared to that of fission reactions. That's all for today. Thank you and have a nice day.